Hi everybody, welcome back to Mooniverse. So in this video, we are going to see about the shortest remaining job first scheduling algorithm. So actually, this is the extended version of shortest job first algorithm, which is having a special feature added into that, which is nothing but preemption. So a shortest job first algorithm with preemption can be said as shortest remaining job first scheduling algorithm SRJF. Welcome to the video. So preemptive SJF, or we can simply say as shortest remaining job first. So let us get in with the illustration. We are considering four processes arriving at different time. That is, initially the P1 enters into the job queue, then continued by P2 and P3 at 4th unit of time and P4 at 10th unit of time. Now let us see how the SRJF algorithm is going to deal with this. At 0th unit of time, the process P1 enters into the queue. No one is there for the competition and the processor is being idle. The process P1 enters into the processor for execution, and it gets executed until the 4th unit of time, where the processes P2 and P3 arrives. Now we are going to calculate the remaining bursting time because the process which is currently running inside the processor has to be preempted if the jobs arriving is having lesser burst time. So we are going to calculate the remaining burst time. As P1 has executed for 4 unit of time and its burst time is 8, the remaining burst time will be 8 minus 4, that is 4. So now we are having three processes P1, P2, P3 with burst time 4, 10 and 3 at the time P is equal to 4. Now among this, the P3 is having the shortest burst time. So it is a preemptive. That is, the process which is running in the processor will be getting out if some other priority process enters into the ready queue. So now the P1 gets out of the processor and P3 enters into the processor with the shortest remaining time. Now the process P3 starts to execute, and it is executing for 3 units of time and it's completing its bursting time. So it's time for the P3 to leave the processor. Now with the remaining processes P1 and P2 with the burst time 4 and 10, P1 is having the lesser burst time. So during the 8th unit of time, this P1 will be entering into the idle processor, and it is being executed for the rest of the 3 unit of time. At that time, P4 enters into the ready queue. Again, we have to go for comparison. So already P1 has completed 1, 2, 3, 4, 5, 6, 7, and its burst time is 8. The remaining time of this P1 will be 1. Now we have to go for comparing the processes so that we have to find the shortest process, that is the process with the shortest burst time. So now P1 is having the shortest burst time with 1 unit remaining. So it is will be continued in the processor, right? So after this, the P1 exits the ready queue. Now the process P2 and P4 remains. Among these, the process P4 is having the shortest remaining burst time, right? So P4 will be entering into the processor and it will be executing. As there is no interruption of processes, it has completed all its burst time in the processor and it leaves the processor. Now only one is left over, that is P2, and there is no interruption of any other process entering into the ready queue. So it will be executed for the remaining burst time for the 10 units of time. So now with the execution, we have made our Gantt chart ready so that we are going to calculate the completion time. So completion time we have to take directly from the Gantt chart. So P1 is completed at the time of 11th unit of time. So I have written as 11. Coming to P2, P2 has completed as 25th unit of time. So we are writing it as 25. And for P3, it has been completed as the 7th unit of time and we are writing here as 7. And for P4, we have completed it at 15th unit of time. So I have written this as 15. If the Gantt chart is perfect, the calculations are very simple by just writing the completion time perceived from the Gantt chart. Now we have to calculate the turnaround time, which is nothing but the completion time minus the arrival time. So the arrival time is in this column and the completion time we have written in this column. So by calculating, I'm getting the turnaround time as 11, 21, 3, 5. And as an average, we have to add up all these things and divide it by 5, which will be giving you the answer as 10. And we have to calculate the waiting time. Waiting time is nothing but turnaround time minus the burst time. So we have calculated the turnaround time over here. The burst time remains in this particular column. So 11 minus 8, it's 3. 21 minus 10, it is 11. And 3 minus 3, it is 0. And 5 minus 4, it is 1. And the average waiting time is calculated as 3.75, which is the average of all these waiting time. Hope you all have understood the shortest remaining job first, or else we can say it as preemptive shortest job first. So we can see the advantage. So advantage is the average waiting time is reduced and turnaround time is also optimized. And each process, if you are estimating previously the execution time, it will be maximizing the throughput of the execution. The disadvantage is when the long process or waiting and continuously the shortest process or arriving into the job queue, the long process will be put on to starvation. They will never get a chance to enter into the ready queue. And another one disadvantage is it will be this particular shortest remaining job is going to calculate the shortest job for every unit of time or whenever the process, a new process enters into the ready queue. This will be increasing the calculation of remaining bursting time, right? So this will be always going for switching over the process from the ready queue to the processor. So this will be increasing the time and it will be increasing the it will be decreasing the processor's performance. And also it is very difficult to predict the CPU burst time in earlier and it's less efficient when we are going for too many processes or coming and we have to go on calculating everything. All the things will be increasing the complexity of the running SRJF. So it will be a less efficient. So thank you. Thanks for watching. So let us see in the next video of CPU scheduling algorithm very soon. Thank you.